Now I pass on the session to Prabha ma'am. She will officially introduce our speaker.
Thank you, Ashiba, for the warm welcome for our today's guest, Dr. S. Shanmugan, PhD PDF professor from the Department of Research and Discovery, Physics, KL University, Vijayawada, Andhra Pradesh. We welcome you, sir. We thankful for the accepting the invitation and joining with us, sir. Let me hand over the session to you. Go ahead, sir. Thank you, sir.
So very title and you are selected for this convener. So this chance you can utilize for the some experience I can share here. Just my what I have learned this last 15 years. So that based on my full-time PhD level and MTech thermal engineering and AI MTech. Now I am doing the Madras IIT. So this based on how I can improve for the based on the research and the PDF. What two country I completed the PDF. That country what learning and here our country what they are developing for the education systems. This based on overcome my experience I can share with you a few words. That's called I given the here that the convener title given the patent drafting. Okay, and individual and property how you can write. So that's a IPR how you can fill in. So this title given. This title based on common guidelines to approach for the patent and Indian national and international how you can approach. Then come to the our academia how you can approach for the engineering innovation to the my research now working current hydrogen production and how you can green field you can approach for the solar desalination towards based on the sustainable process feature which goal you can achieve. This all are curriculum based on our NEP 2024 policy we can follow. So that only our profile also will develop such student life. First, as per the faculty profile with curriculum is there. So that well done curriculum you can growth for the students. Students means our child. That child how you can approach how they will growth of the technology after then skilling you can gaining then only you can secondary group they will approach. Otherwise they are rejected. They techniques is there. That techniques you can see the gear you can use it to the IPR. Second one is you can use it to the gear matcher the IPR. So fifth one is your role of the academia and the research what you can improve the your technical point of that point of you can see the first point you want you will some innovation you want some using for the new this is all opportunities you can utilize the government sector very useful to you based on the STEM material you can how much technical strength is there that's the based on the legal that protection how you can interact for the some global for that's all you can tell you the importance of the IPR. So fifth point practical or you can do the some theoretical values or you can do the simulation model that based on you can do the useful or you can do the some any industrial application oriented. This is a very important the curriculum. This based on the patent ability criteria you can use it here three techniques. One is you can use it the novelty. Second one is you can say innovative and the steps. Third one is industrial applications. Okay, so already you know novelty means any new ideas. Who is already published that paper don't take any new idea only responsible. That's called you can tell in novelty. Innovative steps means already that's some creative new techniques, that's a method, or you can to some improve your efficiency, that based on you can significant you can improve for your innovative techniques. Okay, the third one is industrial application means some your prototype you can develop, that prototype very useful for the industrial, so that's some benefit of the practical values also, that values only you can approach for the some utility, or you can use it the application levels. These all are you can use it the some scientific principle also you can approach, and you can develop for that patents, otherwise they cannot patent publish it. Okay, so another point, they are learning and compound of the patent and the specifications, what you can see the here inventor and the patent request and the society what use your patent. These all are you can patent office, they will approach here. Okay, so this some parameters that parameter you can use it here: title, abstract, field, background, summary, and the descriptions of the drawing. After then detailed or their descriptions and the claims. Okay, so these all are the parameter. That parameter based on you can how you can approach for that filling the form. That form inventor right now. So that's a they will ask to you your sign also. So this pattern very specifically it can use for very technical document only. Remaining document anybody unnecessary they are not considered for their pattern. Particularly the patent office you can use it here only main focus of the inventions. That invention you can use it the how it is work and what exactly is being you can claim it for that prototype. Okay, so this is a very important. Next point, come to the patent specification. You can use it here 10 step is available. That is 10 step already I said to you. So based on the title, how you can how many words you can prepare, minimum 15 words. So that's a preferable. That values you can see the very good innovation based on the your subject wise only. But guys, also is some biology material is there that if applicable you can add it. That's a good sound. Okay, so that otherwise you can leave it for the DNA and RNA that the animals also, that's not necessary. Okay, so after then the next point you can fill in the how that how you can fill in the procedures. That's the Indian and the international. This is one of the curriculum very important. This Indian pattern already several steps is available. That step what your priority you can give this some drafting, that is specification filling for the patent application. Some publications very important, already I said some publication already skilling you want. Okay, it is request very examinations of responding for the your FER and the grant. Okay, so that's a very useful to you. Then come to the international filling the pattern. That pattern, if you want to see PCT route, that's a very important. That call you can see the some include for the your international application levels. Okay, so for example, application level you can do for the here green technology. So this is a international global very bomb. Okay, so that also you can you can use the AI tools based on the machine learning, any XGBoost or any CNN, and you can algorithm you can do. That's a very application to the suitable for the international application levels. Okay, so such as you can use it here reports, publications, that support file. What I telling to you, support files. So that's a reports, publication, and optimal preliminary what you have done examination and national space. Entered everything you can analysis here. They will analysis, then only they will give the approval. Okay, so this pair is you can conventional you can use it as some application level. It can be filled directly multiple countries within the 12 month. You can your patent days you will publish, you will get it. So, okay, so this is a very important. So then come to the what's the difference between you can telling here Indian and the patents. Okay, so that patents also so based on the production and the priority and the examination. Fourth point is cost. This fourth point is very important. This along Indian filling and the PCD fillings and clearly you can write in the your language style. that based on the avoid unwords. Okay, so that's called, you can see the here unnecessary words, don't add it. So that's the meaning. That technical, and you can what you can telling, what you can improve, that script and start you can write here. Okay, so fourth point you can telling the here the focus and the claiming dropping. Okay, so what you can production you can do the dropping that board, that board how we can claiming your patents. Okay, so that's they are telling the here narrow depend claims. Okay, so directly what your work, what technique, what your problem, everything you can directly you can write. Okay, so fifth point you can say support claiming and the detailed for the description, how what you can writing step by step you can explain here, that based on the working model and element, and you can describe and some specification also you can add it. Okay, so include for the some variation and alternatives you can use some coding or any algorithm, what your material, or some mention the possible modification materials and range and optical features, that all you can write the some words, that more no need more explanations. Okay, so that legal and technical and balance how you can get it, so that the draft must satisfied and the legal requirement, then you can use it for the term technical accurate, avoid to the unnecessary limitation unless requirements. Okay, so that's a very important. This based on you can see the some loop is there, that loop IPR timelines is there, that's a, if you want yes you can go, or no you can remove, again you can add it. That's a loop. That loop based on the flow chart, that flow chart you can see the here how invention you can expose, how you can stable you can write, after then how finally file the application levels. Okay, so finally these all are the basic guidelines for any patent you can national or in international you can apply. So that's a patent guidelines. Now you can understand what is meaning of the patents. That's all you can telling the here legal you can production you can use it the some novel inventions. That's the first point. Second point, you can use it the here any material you can prepare, that's the rights, after then you can get it the after 20 years. Okay, so third point you can see the some production how the very useful for the societies, that based on the your filling patent. Okay, so fourth point you can patent how you can approach, how you can attract for the your prototype based on the society or some industrial, how you can approach for the invention, and technology how you can transfer to one place to another place. That all the fourth point is include, that is called one word you can telling the patent. Okay, so this patent you can use it the here some method is that, that's a patentability and patentable. Okay, so this is a very important, that's called you can India how you can use it, and the patentability criteria how is that. Okay, so patentability criteria you can use it the here now patent filling after grant. Okay, so this is a very important. Some coming the patent communications, if you want license you can get it after 20 years, you only owner. After some technical transfer also, some patent good patent is there, some industrial guys they will approach to you, after then you can get the good package. Then some sort of incubation also you can own, you can make it. So after then your real income you can increase your package. Okay, so after then you can see the here international filling the form, that form you can simply telling the PCT routes. Okay, so that route one filling, after then you can directly you can protect protection for the your 157 countries visible your patents. Okay, so then you can some key step is there, that step you can use it, they get some report ISR, and after then rating the options, after national space enter how you can overcome that also this available. Some role of the research scholars and the faculty members, you can approach for the content novelty searching and document the experimental. More than experimental is available, prototype very useful to you, very curriculum is very more you can get it. Okay, so that identify inventions and earlier you can get it. Some collaboration you can do with IP or cell, your you can approach any funding agencies, you can get with a good funding to you. Okay, so private sector or government sector, any NIT, IIT, you can see. So who is got the good proposal? That proposal you can see the here that PA person, any interact for the industrial or any international, or we can go for the some already background more publication and the patent and the grant they will get it, then only that guys only will get the more funding proposal. Now current situation MNA or E or DST or DST self we can approach, they are your profile who is the principal, we can prototype, we can make it. After then how approach for the industrial, that industrial how they released the our prototype to the societies. Okay, so this call we can telling the science, engineering and the technology to the your industrial application levels. Okay, this 4-5 steps you can grow, then only your project you can get it very easy. Otherwise nowadays funding agency not give to any monies. Okay, so this is a very basics why hydrogen is important current situation societies. Okay, so that first of all you can understanding hydrogen already you know that based on the various energy sources. Okay, so this is the first point. That point you can use it in the hydrogen, you can only clean fuels. Okay, so that exactly you can use it that using only from renewable energy sources. Okay, so method of the hydrogen production you know that's the 4 types only. So that based on the water electrolytes and SMNR and engineering innovation one words. Okay, so come to the main method of the hydrogen production, you can use it the here main focus of the 5 technical is available. That's called you can tell in the green hydrogens. After then SMR, MR. After then you can tell in the here biogas, and another one is the photocatalytic water splitting and thermal technical cycles. This all are you can use to the which purpose, where you can improve, how you can growth of the hydrogen. That also you can experimentally you can use it. Then which one is you want and you can select and you can as per the CS engineering or ADS or any mechanical engineering or triple engineering or any you can go the civil engineering or any physics chemistry. This all the which based on the your department and you can approach. Nowadays current situation hydrogen plus based on the sustainable energy you can approach A and ML. More proposal is opportunities now open MNI recognition. And after fourth one is you can tell the multiple applications, and fifth one is you can see the here your reduction emission you can full reduction you can get it. Okay, so that's called you can tell in the hydrogen help of the achievement in net zero targets. Okay, so this target based on you can see the advantages. Come to the another this based on the all curriculum, some disadvantage also is available. Okay, so that the disadvantages what is there, we can telling the here high cost and the energy incentive in the and then you can storage challenges, and after then infrastructure limitation and safety concentrations. Okay, so these all are the concern you can use it the some conservation energy sources. That's a simple they are telling here. Okay, so conservation energyable you can use it here, renewable energy or non-renewable energy you can use it. Some drawback is also continuous day by day coming. Okay, so that continues you can how overcome you can get it. So that's why we are going for the here macro to micro chem, micro to nano chem, nano to Armstrong now going for the our research level. Micro to nano chem, nano to Armstrong now going for the our research level. That's a lightweight material, how much valuability we can get it, strength how much you can get it. That's all are going for. So as on 2030 as per the our CM based on you can Prime Minister you can achievement the world NIP 2024 policy, there are some curriculum they are given that only DST and government sectors more funding tie up to the IIT, that IIT guys give the more funding for the private institutions if possible, and you can interact, you can more funding for the your sites. Okay, some prototype you can more funding for the your sites. Okay, some prototype, some technology wise some you can improve for the your prototype methods for the industrial application. Then only they will allowing, after then you can get it. I think 577 crores. They are Bombay IIT given now current project. That project any interact to the IIT professor Bombay. So interact after that curriculum renewable energy based on the hydrogen production. If possible, you can go for the background of the machine learning, or any go for the any AI and ML. Then come to the any physics one professor and CSC one professor. In multidisciplinary, you can writing the proposal, you should get. Okay, so nowadays publication and patent and project, you can multidisciplinary, you can give the document, then only they will select. Otherwise, simple CSC only you can submit it nowadays, very difficult. As per the editor, I am a renewable energy journal editor, so several journals, not renewable energy journal, several journals also current situation they are not accept papers. Any possible one paper, any JCR journal you can submit within one time, any journal you accept. Nowadays current Indian papers anybody not accept easily. Okay, why miss? Several sort of is there. Okay, so that's a ratification. Several our Indian name remark came. Some private institution unnecessary make for the what telling, that's that paper already published, that's a software you can recycle, after then modified some title, some content modified, some same story they will send it. Some editor level also some software is there, that software we can upload your paper, after then to show it, this paper where you can take, how you can recycle, you can get it, everything we can identify. After then within 24 hours or within 48 hours, as per the norms, they are taken time 1 month. Okay, so high quality journal they will take 15 days, 1 month. After then they will simply telling your paper is rejected. Okay, so as per the faculty, and you can give the guidance, good guidance to the student. After then they will properly research you can do. So good quality paper you can write, after submission you can get within 45 days any high impact factors you can get it. Recently we are my students all get it here 16 impact factors. Okay, so that's a nano energy journals. We are genuine worked within 45 days we get acceptance they are given. Okay, so that's a real work only they will give. Okay, so some chat GPT or Gemini you can software you can use it, that's a not good research. Okay, so business is different, research is different. Okay, really you are thoughtful and you can improve the your growth and your child also growth and your students also growth. Some institution also you can growth, you can get it. So my suggestions, you can do the some advantages, some technique prototype you can do, some time daily or half an hour, 1 hour you can do good research you can develop. On paper 3 months you can develop. As per any private sectors, they will ask to you only after PhD, that the faculties they will ask you not 100 paper, not 20 paper, they are not asking. Minimum for as per the grade for assistant professor, associate professor, professor, there is some grade they are giving the norms, 2 paper, 3 paper, 4 papers. That's the norms. That norms only quality we can make. Several 365 days is available. That you can make some quality paper. After then you can get your CV also good growth. Some ratification also avoid. So overall India, some universities very more came. What meaning is that's they be some engineering students all doing students, how that as per the faculty mentor you only approach, though this is not correct, that all society how who will develop, our academia only will develop. Okay, academia means child, that students is that students good encourage to you good habit you can develop, that habit goes society they will develop. Okay, so that's a very important, so that level you can improve the your curriculums. Okay, so come to the your engineering role, that's why I am telling that these words. So why are you can engineering crucibles? Okay, so that's a very important, that point only I am telling the guy. Engineering plays nowadays that all roles you can fundamental roles in the shaping society, very important. Okay, so after then driving innovations. Okay, after then solving global challenges. Okay, so this all are the engineering only they will improve, not doctor, not science. Okay, so this work how you can extend technical wise and the design, that building how you can system you can develop for the technology and the infrastructure and the support to the our human modern life. Okay, so this is a very important. Some to the third point, you can see the some clean energy you want to use some building structures. So how you can medical device how you can develop, then you can digital communication, how engineering transformer scientific knowledge. That's a very important. Okay, that's the communication research. That's called, you can telling the software technologies. Okay, so you can use the experimental, practical, or experimental. You can verify some sustainable solution, and you can improve for the quality of the human lives. These all are, you can see the here engineering crucibles. Okay, so come to the, you can see the some point is available, some parameter is there. That parameters what they are telling the here problem solver under real world challenges. How you can real world you can challenges you can get it. Some analysis, some complex problem is there. That problem how you can develop, how effectively you can cost analysis. Then come to the your innovation solution, how you can approach to some technologies. Okay, so this is the main point. After then you can how you can journey you can start for the sustainable development. Okay, so that's called, you can tell in the SDG. Okay, so this SDG, you know, that's a total 17 goal is available. Among this engineering only you can do the year SDG 6, 7, 9, 11 and 13. This 5 SDG goal adapt for the engineering only. Okay, so engineering directly you can SDG goal how you can see the here as per the clean energy and the sanitations. Okay, so this all are, you can see the civil engineering or mechanical engineering. You can use the water treatment and the pumping system and the desalination process. Okay, so SDG 7 you can see the here affordable for and the cleaning energy. That's the meaning who is adopt here. Solar energy, wind energy, hydrogen and the storage system. That all we can easy and action. Oxygen how splitting and hydrogen how storage. Okay, so this based on the A techniques I can improve. Then finally this overall conclusion, you can see the primary energy sources, future generation, some technology innovation, storage solution and policy supports. That all you can improve how you interact for the water and the wind, biomass, gold and petroleum and nuclear fuel and geothermal, how we can interact for this all source of the energy source. Okay, this source of the energy source I can use the renewable energy, solar energy, wind energy, bioenergy, tidal energy, geo energy. These all are among this I can improve the 299 papers I published the here all solar energy field only. Different materials, different nano fluid, nano composite, and based on the some CSC background also, ANN and CNN and genetic algorithm and XGBoost, that some algorithm I can improve. So along I good high impact factor JCR journal I published this learned area. This area you can use in the future trend for the solar and wind and storage technology. The three technologies you can improve for the some clean energy sources adapted for the sustainable power supplies. Okay, so non-renewable energy you can see the coal, petroleum, electricity, fire and dried drug. This all are you can use the some non-renewable energy sources. This based on you can see the here my focus on solar desalination only. Solar desalination means you can telling the saline water converted to drinking water. That the drinking water how you can approach for the hydrogen approach. That's our new ideas. That ideas you can go further, you can use the how work and use the sunlight and heat to the water and water evaporating heating and after then leaving the salt. Then you can improve with the some behind based on the heat thermodynamics process. That process vapor into inclusive that pure water how you can distill you can get it. Okay, that waste of the you can very important. Why it is the very important run. That run of the renewable energy you can use it the solar energy. Provide the fresh water and the coastal and the dry or in remote regions you can use the low cost optimize. Then you can use the eco-friendly levels. Okay, so this level you can approach the some introduction based on the renewable energy and the sunlight. You can improve for the your securities. That securities based on you can see the two method for the solar energy. One is photovoltaics and another one is solar thermal methods. Okay, photovoltaic means already you know that's a directly convert to the sunlight to the into the electric energy. Then come to the solar thermal methods. You can use it the which utilize you can solar radiation for the heating purpose only. Okay, so this heating purpose you can how emerging technology you can advantage you can develop for the future of the renewable energy. source of the sectors. Okay, so this all previously introduced for the some history of the solar power. Already you know this early belongs to the 7th and 19th century. You can develop it for the some solar 7th century. You can use it for the some humans and modify it for the some gas concentrate for the sunlight and your fires. Okay, then Greece and Rome, the solar energy was utilized for the heating building using the passive solar design and the principles. Okay, so this is a very important. Then come to the your scientific discovery, 19th century. You know that's 19th century only they are developing with the solar power. 1839 employed he can use the Becquerel. What is the discovery developed here? Photoelectric effect. Already you know. Okay, so total amount of electrons, how much you can interact. Okay, so that's based on the material. This called you can tell the photoelectric effect. That total amount of Quantum energy, how much you can use it. That's a photoelectric effect. That effect you can certain material generate an electrical current when exposed to the light. Okay, so that's all he is explained. That discovery you can develop for the photoelectric cell. That cell you can see the 1973. That's a Smith. You can discovery. You can photo conductivity of the silicon material is developed. Further contribution to the understanding of the light to electricity conservation they are implemented. Okay, so this is a 1873 is explained. Some first solar cell and application late 19th and early 20th century. What they are telling 1883 Charles what he is telling the selenium based on the solar cell almost they are reached very low efficiency. He is telling. Again, come to the another scientist Einstein is explained photoelectric effect in 1905 for the which he is received for the Nobel Prize in Physics background. It is provided the theoretical values based on the photoelectric photovoltaics technology is improved. Okay, so 1954 that Bell Laboratories they are developing a first practical that's experimental silicon solar cell with an efficiency of around 6% they achieved. Okay, so this is 1954. Again, this marked significance and milestone in the development of the modern of the solar PV technology they are improved. That's the government sector. They will funding also they will allow. Earlier, this application solar cell included the powering space satellites in the 1950s and the 1960s. In between, they are developing for the solar cells. Okay, so development of the commercial late 20th century to 21st century. This oil crisis of the 1970 that you can see the here sporters that function they are renewable. You can see they get interesting to the renewable energy sources including solar. Okay, so that's a education policy also they are included here 1970 onwards. Okay, so that's they are any education as a policy Malaysia education only they are developed here 1971 I think. That relevant only you can see the that's called you can tell in the TR level only Malaysian country only they are introducing the engineering. Okay, so this based on the interesting research and development efforts that resulting you can improve the solar cell efficiency and relevant to the manufacturing cost. This based on you can more 20 and 20 energy storage. Okay, some here see so that chemical bond. Some here see. So that chemical bond, van der Waals function, what reaction it can do inside van der Waals function, what reaction it can do inside the molecules, water molecules, then inside the molecules, water molecules, then one particle how we interact for the 100, one particle how we interact for the 100 molecules, how we can adapting for the one particle, that particle how the 1000 molecules adapting the one atoms. Okay, molecules adapting the one atoms. Okay. This all of the process you can see the here all of the process you can see the here so after then finally you can get the green color some chemical extract color that extract you can use it the here some rainbow color it will form you can use it the here some rainbow color it will form or not you can verify the engineering colors that color you can so you can see the engineering colors that color you can so you can see the here that electrospinning, you can hear that electrospinning, you can magnetic stirrer, you can use it. At the time rotating will come, your electron, your material very good quality, very good electron, your material very good quality, very good electron adapted here inside that molecules, very fast spinning you can get it. That electron, how much stability we can get it here, that's a, you can tell in the here atom structure, that's called spinning Bohr atom structure. Okay, so that structure also you can see. After then, before you can see, after then, before you can understand the sunlight, how you can new material, you can understand the sunlight, how you can new material you can select. This based on the natural phenomena material you can select and every place and every movement. That's a very important. Two light waves and lower or higher wavelength you can form it, or you can sell in the same amplitude. This based on the optical infrastructure or light infrastructure you can see. So that's what he can understand in the here material. Inside that material, how much already atom structure is available, how many naturally vibration will get. This is a winning. After then, how much spinning you can get it based on the Newton ring, how much you can adapting the spinning. That's a wave mechanism, how much naturally they will adapting the spinning. That's a wave mechanism, how much naturally they will occupy. This all are the, as per the researchers you can identify. Then come to the one molecules, how much interact for the colors, which color you can more interact coming here. That's called, you can see the here rainbow. That water one molecules to another molecules bubbles, how much you can evaporation, more fast evaporation you can. That's called, you can telling the evaporation of the particles. Okay, so you can see some the earth some distance after then more evaporation molecules only will evaporation will do. That's a more particle only the analysis. That material you can see the sun, how energy interact for the sun. That sun energy we can see the here more type of the, already I said to you. So very energy useful to the our photosynthesis work is very useful to you. That material you can base on the classification and you can use the thin film materials only. Okay, so as for engineering we can follow the thin film technology only. That technology you can see the here some silicon material, some semiconductor material, some emerging materials. Okay, so this based on the structure, which one is if you want and you can select, then only you can proper academic process you can follow, then only you can get to the your prototype work very easily. You can achievement you can get. That's achievement means you can tell in the some publication you can get it. Okay, so this material, how this argo material you can collect, after then how you can activated carbon you can do that process also. If you want some method that absorption material, that some particle how predicative you can analysis for the profile, that performance how much you can water evaporation you can rate you can. That's called, you can tell in the here Fourier transfer emission transist, you can tell in the words ferrite. Okay, that ferrite energy analysis you can do the here lower energy to higher energy, in between how much you can photosynthesis process you can tell. That's a quantum wave mechanism, how much you can wave function you can analysis. That all are based on the your chemical energy to convert to how much you can utilize it. That energy only you can see the here reactor, and the chemical energy you can how much solar energy absorption. After then your prototype how much you can get it the energy level, total amount of energy level. That example you can see the here any water inside the any stone you can keep it and some element will come. Okay, that wave, that wave only we can see the here, you can see the here, that's a wave mechanism. That wave mechanism only you can tell in the here how we can, how much pumping you can do. That's a superposition values. Okay, so that superposition on the activated carbon you can see there's some chemical you can add it, KOH or jet Cl2 or H2PO2, that may etc. That material, any one material you can add it, and after then remove agent you can get it. That activities process you can do the some higher temperature you can involve, then you can get to the activated carbons. Okay, that's it. Specifically you can the surface area 500 to 300 300 meters square by gram, you can actually get to the high piece of the porosity volume, you can get it for the microscope for the your histology process. Okay, so this is the process. This is naturally we'll get it the here. This is I got the here 75 crores this project. This project already completed. So this is one of the part of the activated carbon process of the hydrogen storage materials. Okay. Some porosities you can see there's some basic characterization you can prepare. Then you can characterization FTR, XRD, AFM, and SEM XRD as per the characterization basic rule. After then, this porosity, how much you can get it involving for the energy storage. Some process, that process based on the characterization activated carbon, you can do the here some physical and chemical you can interact for the some advantage of the material. That material you can process, you can see the some characterizations. Okay, so this classification you can see the activated carbon. Again, that carbon we can use the solar desalination systems. That desalination systems you can approach before you can analyze the A and the ML process. That ML role is you can use the energy production and reduce the cost. Okay, so that's called the predication values. Okay, so energy predication values we can get in the A and the ML role. That role you can see the here we can use it the here passive solar desalination. You can use it the here two way. One is a passive solar desalination, another one is a active solar desalination. Passive solar desalination means we can naturally evaporation will get it, but active solar desalination you can give the extra source, then only evaporation run. Otherwise we cannot. Okay, so this solar you can see improve the classification system. This is a basic solar energy system. That system you can use the symmetric only. We can focus the our area. That area process first we can analyze the material select. After then synthesis process, that all full and full we can use it here orgo waste materials only. Okay, so after then we can make the carbon. After then inside the coating materials, that material inside the naturally will get to the summer days we can get the more temperature heats. That's say here more vibrate we can get it the here that oscillation for the atom structures. Okay, so that's very important. That important based on the we are for our desalination system. That bond to one bond to another bond, how we interact for the more molecule structure. That structure, how the mechanism we can get it the wave function. That's the interactions. Okay, so one molecules to another molecule wave mechanism, how the connectivity will get it. Okay, so it's the sewage material you can see the here really you can very more interact for the our desalination system. This solar you can use it the here interaction solar desalination you can using for the techniques of the parameters. That's called PEM and AEM and alkane electrolytes. You can use it here. That based on the material parameter compound. Okay, so this all are the how much you can quality you can get it. This based on you can see the here category wise. You can use it the PEM electrolyzer and the AEM alkane electrolyzer. We can focus on AEM only. Okay, so that material you can see the here which values you can get the 0.04 you can get it the values. Then come to the you can intensities binding stitching you can get it here around near for the 350 you can reach the more peak values you can get the lithium power. So that's the structure XPS. Okay, so that XPS values you can see the values based on the standard values. You can adapting the binding energy that relevant to the 0.0 electron voltage. You can adapting the more efficiency you can get to the lithium materials. Okay, so this is a binding a different material you can analysis that based on the material how where you can get it here high interact for the some particle size. That particles also I taken the gear SEM and 10. Okay, so that's you can very high revolution 10 taken. So this average predicate values you can percentage how much I can get it here 4.4 nanometer 480 nanometer we are achieved the particle size. So that particle is more interact for the hydrogen productions. Okay, that material we are using the activated carbon lithium and Na and Ru material where seating the our element. That's the ADAX characteristics also here done. So this based on the thermodynamics process and you can see the here HOR. That's a hydrogen you can relevant how the relevant interact for that compared to the platinum material. Our lithium material is very high efficiency you can get it. Okay, so based on the you can energy level efficiency you can see the current values. You can see very high interact for the lithium based on the materials. That interaction you can get to the here electrolytes at a spectrum. That spectrum based on the you can how much accelerated turbulity you can get it. That based on the initial mass how much active vibration you can get it. That's some comparison studies also done. This based on you can see the electrolytes. You can see there's some in between platinum and ruthenium material, which one is more high efficiency? Our material you can achieve the here 100.20 centimeter, which is the active material you can achievement you can get it. Okay, so this based on material you can see the here some analysis of the optimist where that during time that how much you can interact with the or based on the current voltage. Okay, so that current voltage you can get the here catalysts that values how much you can get it the some compared to the other studies our catalyst, then loading give that present values you can very high values you can get it. There's some with and without and you can doping with without doping also you can compare some ARN materials. Okay, this based on you can see the here some recent current and that how much time it can taken that values interaction or some analysis of system. We started the 75 seconds. After then you can achievement you can get it the here 800 to 10 you can achieve the here stop. That's after then that is here no pollution will not come. That percentage also we can calculate it here very more. Okay, so that's a green color you can say 44% you can achieve the our ruthenium materials. Okay, so this is a reduction of the carbon dioxide chromium characterization. This based on you can see the here ruthenium material you can comparison energy level how much magnetic loop you can get it. Okay, so the ruthenium material you can get the 0.14 voltage very more efficiency you can get it. This based on the same some different you can analysis for the here ruthenium material that 0.7 voltage here very more popular magnetic elevation you can get it. Okay, so this all are the very chemical adaptations that material some intensities from how much you can binding energy you can get it the PNC techniques and some electrochemical also you can XPS you can adapting for the some interaction. That interaction for the some our material we can use it the solar desalination after then process inside the boiling. Then you can process you can very naturally you can get the achievement. This design you can get the good per population within the desalinations. Okay, so some our videos you can see the here some our BTech students here achieved the more achievement that based on you can see some 1 or 2 minutes I will show it that videos, please excuse. So here drop by drop coming, so more efficiencies and that's a purification water. That water you can get it the here directly hydrogen production based on the solar desalination systems. Okay, these all are the our BTech students only achievement is there done. So some another videos also is there some just 1 or 2 minutes only, not so it more times. So this is the BTech students, third year students, CSE only. He is a CSE background, but he is achieved for the ML and AA. He is also now one patent published and 2 QM journal published. So now he is studying the 4th year student. So last year he is worked in my lab. So he is also placement got the 57.5 lakhs in Japan, Tokyo industrial company. So that's we are our lab working who is working the students very high quality journal only published, but experimental some algorithm coding also we are developed generate, then we can approach for the experimental also. Then come to the another slides. That's another guys also this hydrogen production how we generate for the machine. So involving the solar desalination water it can interact. That interact after then bubbles will that bubbles only you can tell in the hydrogens. That's a hydrogen production only done. Again we will can try to the storage. So this is a very important. So come to the another hydrogen production values how we can interact for the solar desalination then your process. Okay, so this is our new materials. So some analysis we are calculated the morning to evening. Some calculation you can do the solar radiation to ambient temperature. We are get the more peak values only very high intensities you can observe our materials. So along after then you can gradually decreases also will get it in both parameters. Okay, so again come to the here average solar radiation you can calculate this winter section also same values. Some you can get the energy or total average values, how much energy absorbs the solar radiation. So
no more queries. Shall we go for a valedictory, sir?
Okay, madam. Okay, thank you, madam. Thank you. Thank you very much, madam, given for this opportunities.
Thank you so much, sir.
Yes, thank you, madam. Thank you. Thank you. I can leave, madam, now.
No, sir, please wait for a few minutes, sir. Let us complete the valedictory, then we will wind up the session, sir.
Okay, madam. Okay.
Ashiba.
My slide is closed, madam.
Please, sir.
Okay. Okay.
Let it be, sir.
Okay.
May I start now?
Yes, yes.
Respected speakers, esteemed resource persons, the dignitaries of the Panimalar Group of Institutions, organizing committee members, faculty colleagues, researchers, and dear participants. A very good evening to one and all once again. It is indeed an honor and privilege to gather here today for the valedictory session of the national level 5-day online faculty development program on building expertise in research paper and proposal writing. As we conclude this remarkable academic journey, I extend my heartfelt gratitude to the management, organizers, speakers, and participants whose collective contributions have made this FDP a resounding success. We remain deeply grateful to the visionary leadership of the Panimalar Group of Institutions. Our sincere thanks to our Chief Patron, Dr. P. Chinnathurai, MA PhD, Secretary and Correspondent, for his continuous encouragement and commitment to fostering a research-driven academic culture. We express our profound gratitude to our patrons, Mrs. C. Vijayarajeshwari, Dr. C. Shakti Kumar, and Dr. Saranya Sri Shakti Kumar, directors of Panimalar Group of Institutions, for their unwavering support in empowering scholarly initiatives. We also extend our appreciation to our co-patrons, Dr. K. Mani, ME, PhD, Principal, and Dr. S. Prasanna Devi, BE, ME, PGDHRM, PhD, PDF, IISC, Chief Academic Officer, whose guidance and academic leadership have played a crucial role in shaping this FDP. Our special thanks to the Department of Artificial Intelligence and Machine Learning for conceptualizing and executing this meaningful program under the leadership of our convener, Dr. B. Annie Princey, ME PhD, Professor and Head of the AI/ML Department, along with the dedicated coordination of Dr. B. Prabha, Assistant Professor Grade 1, and Dr. R. Anand Babu, Associate Professor, and also Nagraj Sir. Their meticulous planning and tireless efforts have enabled a smooth and impactful learning experience for all participants. This 5-day FDP witnessed exceptional participation from across the country, with 100 plus registrations representing reputed institutions, including Christ University Bangalore, Samram University Bangalore, Presidency University Bangalore, GMR Institute of Technology Andhra Pradesh, Mallareddy University Hyderabad, KL University Vijayawada, Takshashila University Tindivanam, SRM Institute of Science and Technology, Kalathur, Vadapalani, Chennai, and several others. The diverse representation and enthusiastic engagement enriched the academic discussions and propelled the success of this program.